everyone. So we are going to continue our discussion on random sampling here. This is from section 1, 2. I'm starting with this list of definitions here, and I did post this so you could either print it out on your own or copy them ahead of time. I'm going to kind of go through this assuming you've already at least read these or written them down. But if you need to pause the video at any point to catch up with copying them down, feel free. So these are all terms that kind of refer to sampling methods and other types of sampling, and several of them really are random samples. Okay, so I shouldn't really refer to them as other types of sampling because they are still random samples. And I'm going to give you some examples of each one. So first off, replacement sampling really just refers to the practice of, like, once a number has been chosen in your random sample, it's thrown back into the pot and could potentially be chosen again. And sometimes you want that to happen and sometimes you don't. And if you don't want it to happen, but you're using some sort of tool like a random number generator that does do replacement, then you can kind of just throw out the duplicate. So let me show you what I mean. This right here is the simulation that I ran, at the end of the last video with the heads and tails, okay? And so 1 was heads, 2 was tails, and I was okay with having these multiple ones in a row because that just represented me getting heads more than once in a row. So that is an example of replacement sampling. Once I chose the 1, it still got thrown back into the mix for me to choose again, okay? Your calculator always does replacement sampling. So let's suppose that I wanted to do a random sample of 10 students. And obviously when your sample size or when your population size is low, you're more likely to get repeats. So let's say I'm choosing from 1 to 10, okay, and I start generating my numbers, and I don't know, right there. So I ended up drawing the 4 twice, but I don't necessarily want to include the same student in my survey data or whatever I happen to be doing twice. So in that case, I would kind of just ignore that one and keep going to my next number. So let's suppose I were trying to draw 5 different students here. I drew 5 numbers, but 1 was a repeat, so I would just draw 1 more. Okay, so that's what I mean by replacement sampling. These next 3 are really types of random samples. Okay, sometimes though it's not real practical to just throw everything into a random number generator. And sometimes there's reasons that you would want to divide things up into groups or something like that before you start doing random sampling. So let's first talk about this one here. Stratified sampling involves dividing a population into 2 or more groups called strata and taking random samples from each strata. What I want to emphasize about this method here is these groups should have some statistical significance. And I'll show you what I mean in just a minute. Okay, so let's suppose I'm trying to take a survey of the students at Jenison High School. Okay, I'm trying to gather some data. And I'm going to kind of stick with that same example all the way through and show you some different ways I could do that. If I wanted to do a stratified sample, I might divide them up by grade level. So I might take a list of the 9th graders, a list of the 10th graders, a list of the 11th graders, and a list of the 12th graders. And then I'll take a random sample of each one of those groups. So if I wanted to survey 400 students, I would do 100 from here, 100 from here, 100 from here, and 100 from here. These groupings make sense to me. I mean, I guess it depends on what my survey's on. But I could then look at the data as here's how the 9th graders feel versus here's how the 12th graders feel. And it might make a difference in their results as to what grade level that they're in. I wouldn't want to group it by something arbitrary like hair color or eye color because that information doesn't give me anything meaningful. I mean, I guess unless it's something that, eye color would make a difference for. But so you want these groupings to be something that is relevant to your study. If I'm trying to get feedback on remote learning from the high school, I want to make sure that I'm getting feedback from every grade level. And so a stratified sample might be a good way to go. Okay. Systematic sampling is some sort of pattern. Okay, so that's the word I want you to associate with systematic. So maybe I take a list of all of the students in the school and I highlight every fifth name. So I count down 1, 2, 3, 4, 5, highlight that name. 1, 2, 3, 4, 5, highlight that name. Okay. And then those students would be my random sample. Okay. Or maybe I stand outside the front door in the morning when everyone's getting dropped off and I sample every fifth student that walks into the building. Okay, that would be another way to do a systematic sample. You would have to make sure that somehow everyone is equally likely to be chosen in that case. But so a systematic sample always has some sort of pattern to it. You do have to watch out for that type of sampling if you're working with, I don't know, something that's generated by routine. And here's what I mean by that. If you were looking at the effectiveness of parts that were created on an assembly line, let's say, maybe there's an error in the programming and the machine is generating like a defective part every 7 times. Okay, so every 7th one becomes defective. However, if you are going to survey it and you're going to survey every 10th one, you're kind of almost intentionally, although without knowing about it, jumping over those defective parts. Okay, so in something like like an assembly line, you probably would not want to do a systematic sample. Okay. Okay, cluster sampling, and a lot of people get this mixed up with stratified sampling. Cluster sampling involves dividing the demographic area, so this is generally more of like a physical space thing, into sections and then randomly selecting the sections, which are called clusters. Okay. An example of that at the high school would be to take a list of all of the 3rd hour classes, let's say. And then randomly selecting. So you would have to incorporate some sort of random number generator. Maybe you're going to throw all of our classroom numbers into a random number generator. But the difference here is that you're going to randomly choose however many classes you want to survey, and everyone's equally likely to be chosen if everybody's in a 3rd hour class. Okay. But then you're going to survey all of the people in those clusters. So if I choose room 220, every student in room 220 is getting a survey. Okay. If I don't choose room 115, then nobody in room 115 is getting a survey. Okay. So the randomness comes from choosing the classrooms and not necessarily choosing the individual students. But technically, as long as everybody has a 3rd hour class, everybody would be equally likely to be chosen because every classroom is equally likely to be chosen. Okay. Multi-stage sampling, I'm not going to get into that a whole lot. Really, that just involves taking more than one of these methods and kind of grouping them together. So if you're working with a very large, unwieldy population, like the population of the entire United States, you may have to do some sort of stratifying and then some sort of systematic choosing, okay? And these typically end with some kind of cluster sampling. So this is just to say that you can take some of these methods and combine them together in more complicated scenarios. Convenient sampling always kind of bothers me because convenient sampling is not truly random, and that's why you have to really look out for it. Okay? Sometimes, though, that's all you can do. Sometimes you don't have any other choice but to work with non-random data. And it doesn't generalize as well. You're going to have a harder time drawing any sort of claim about the population, but convenient sampling would come from something like me standing outside the band room at the end of the day and handing a survey to only the students who are coming into the band room at the end of the school day. Okay? It's convenient for me, right? I don't have to work with any big lists. I don't have to bust out my random number generator. I don't have to run all over the school looking for different classrooms. I can just stand in front of the band room and just hand surveys to those kids. But the problem with that is you're not truly getting representation from everybody in the school, right? You're only hearing from the students who are in band or the students who have a reason to be going into the band room at the end of the day, okay? So convenient sampling, and then any generalization I was going to make off of that, I could really only generalize to students who are in band, not the entire school, okay? Convenient sampling also comes up with like voluntary surveys. Like, hey, I'm going to post a link for you to fill out a survey. Do it if you want to. Okay? Because the people who tend to fill out surveys voluntarily are either the people who want to gush about how great whatever the thing was, or who want to like bash it, who want to say how terrible it was. And you don't get very many of those voices in the middle because they just don't feel compelled to fill out the survey. So any sort of voluntary survey technically counts as convenience sampling. But sometimes, again, you don't have a choice. Sometimes you just put the survey out there and you work with whatever data you get. It's just a lot harder to generalize to the whole population that way. Okay, so speaking of those generalizations, just real quick on sampling frame. Sampling frame is essentially that list that you're working off of to do any of these other types of sampling. So remember I said we could get a list of all the 9th graders, a list of all the 10th graders. That list would be the sampling frame, okay, because that's where I'm choosing my sample from. Ideally, that list should include the entire population. So if I'm wanting my survey to represent the entire high school, I would want the entire population to be reflected on one of those 4 lists, okay? But if I'm working off of something that for some reason excludes some members of the population, I end up with a situation called undercoverage, okay? So like, for example, let's say that I go with this route and I do the cluster sampling and I choose 3rd hour classrooms and I, randomly survey different classrooms and I get my data back and I'm happy with it. What about the students who don't have a 3rd hour class? What about the students who are taking an online class or who are dual enrolled or something like that? Okay, those students were automatically excluded from the sampling frame. And that means that I technically didn't represent my whole population because there are some members of the population that did not get included. Okay, so that's what undercoverage is. Undercoverage is a type of sampling error. So down here, it kind of generally classifies 2 different types of error. When you're doing statistics, there's lots of ways to mess it up, okay? But we take all those ways to mess things up and divide them into 2 groups, sampling error and non-sampling error. Sampling error is anything that comes from messing something up in terms of choosing your sample, okay? So sampling error would be, making a non-random selection from one of these groups up here. Convenience sampling can sometimes lead to sampling error. It's something that you mess up that makes it so that your discoveries or your claims cannot be generalized to the entire population. Non-sampling error, and I cross this out because poor sample design is a type of sampling error. But non-sampling error is anything else you can screw up with statistics. So maybe you didn't do a good job choosing your data. Or collecting your data, I guess I should say. Maybe you asked bad questions on your survey, and that's a whole other issue as far as like making sure that we make things statistically sound. But any sort of thing that you mess up that doesn't have anything to do directly with the sample that you chose is a non-sampling error. Okay, so that's it for this quick video. That kind of covered all of the vocabulary here. I am going to throw up another video that has to do with the examples on the next page, and then you should be good to go. All right, thanks for your time.